Welcome to the podcast, Introduction to Complex Numbers. If you look at the equation x squared plus 1 equals 0, in order to be solved we would have to find a number x such that x squared was equal to negative 1. Of course, no real number has that property because when you square a real number, you always get a positive. So we're going to introduce today a new number system called the complex number system, and a new number so that when you square it you get negative 1. Now, complex numbers were not just invented to solve that equation. They came about over hundreds of years of development and were really accepted by the math community when good uses were found for complex numbers, and I'm not going to go into those right now. They're not a part of this course. But if you need complex numbers as a future course you're taking, your instructor will tell you what their role is in your particular discipline. Let's go on right now and get started by defining what we call the imaginary unit I. It says the definition of I. The number I, called the imaginary unit, is defined by the equation I squared equals negative 1. Now over the equal sign there I have a little d. That means equals by definition. That's what you mean when you see a equals with a d above it. It means this is the definition of the symbol. So the symbol I is defined by the equation I squared is equal to negative 1, and so you could see that I would be a solution to this original equation because negative 1 plus positive 1 would give you 0. Now the number I leads us to a new system of numbers called the complex numbers, so I'll define that here. A complex number is a number of the form a plus b I, where I is the imaginary unit defined right above. A is called the real part of the imaginary number and b is called the imaginary part. If a is 0, all you have is 0 plus bi, which is bi. So the resulting number bi is called a pure imaginary number. Now with that in mind, let's do some arithmetic in the complex number system. The first thing I'm going to do is subtract two complex numbers. Notice that is a complex number. It's in the form of a plus negative 3i, which is a plus bi. So that is a complex number. I'm subtracting that from that another complex number. The good news is subtraction here is just like subtraction with ordinary polynomials. That is, you do the same thing as if that was an x instead of an I. So I'll first distribute to clear the parentheses on the first term. 1 times 2 is 2. 1 times negative 3i is negative 3i. I'll put in my little invisible 1 that multiplies every number right here. So to clear the second parentheses, I'll multiply negative 1 times 4, which is negative 4, and negative 1 times 2i, which is negative 2i. And then to complete the problem, I'll simply combine my like terms. My two real parts are 2 and negative 4. When I combine them, I get negative 2. My two imaginary parts are negative 3i and negative 2i, so when I combine them I get minus 5i, so my final answer is 2 minus 5i, and that is in the form of the complex number a plus negative 5i. So that is in standard form of a complex number. Well, the good news continues. Multiplication for complex numbers also follows the same rules as multiplication for real numbers. So do this problem just like a binomial product, where the I is going to operate the same as an x was. So we start off, to get the first term of our answer, we multiply the first terms and get 20. To get the last term of our answer, we multiply the last terms, and we get negative 3i times positive 2i is negative 6i squared. To get our center term, we do an inside product plus an outside product. The inside product is negative 15i. The outside product is positive 8i. Negative 15i and positive 8i is negative 7i. Now remember our definition for I. In our definition for I up here, we had that I squared is equal to negative 1. Well, down here I have an I squared. So what I'm going to do is I'm going to replace that with the number -1. So I now get -6 times -1, which of course is just +6. So I get 20 minus 7i plus 6, or 26 minus 7i, and that is my final answer, and that is in the form of a complex number.